Pivotal is a sponsor of our ebook series on Docker and the container ecosystem. Learn more about Pivotal's perspectives on these timely and important topics in our latest ebook about application architectures and microservices. It's available for download at thenewstack.io. All right, hey, it's Alex Williams of the New Stack here with my friend Michael Coté of Pivotal, former co-host of the New Stack Alice, and now a well-respected member of the Pivotal family who's here to talk with us about microservices. Hey, Michael.
Hello there.
And today we are going to discuss microservices. And Michael, I would just love an introduction from you about Pivotal and tell us a little bit about how Pivotal perceives microservices and how you see it in the evolution of really this whole new concept of how you build applications and deploy them.
We use the moniker cloud native to describe everything you just said. All this new stuff and how you build new applications and all of that. And one of the things that we're finding as we look at best practices and what people are doing and what our customers are doing is there's really, when it comes to all the new stuff or cloud native, if you will, there's three things that you end up needing. One of them is the what we're talking about here, microservices, right? So that's sort of like the architectural pattern that you use, the way you think about dividing up and architecting your system. The other one is you want DevOps that helps you run your system in production and also helps you think about how you write your system, your software in development so that it can be run in production well. And then there's all of the cultural empathy meatware stuff that comes with DevOps that kind of helps inform what I would call the evolution of Agile into sort of like a cloud era, if you will. And the third one is looking at continuous delivery, right? So continuous delivery is sort of like your process. It's your end goal, your factory. You want to be able to get code, have everything set up, in such a way that you can get code into production daily or weekly or whatever makes sense for you, and start to observe how that code's used and get faster feedback loops. So these three things together, and there's details. I mean, it's always good to think in terms of three, but those are like the core things that you want if you want to do things in a new way. And so we like to talk about all that because we end up talking with people who are really interested in, they realize that like, I'm not a tech company and yet I need to be really good at software and I need to improve the way that my software is done, right? Like across banking, insurance, governments, retail, whatever. Like if you think about it as a consumer, you probably want to interact with your companies through software, right? Like Amazon has this thing now every day you can log in and see if you won a prize. And, won some, I think today it's a Ninja blender, if you're into that. But anyways, every company wants to hustle their wares to you through software more and vice versa. And so to support writing better software and those kind of that triptych of things, those three things I was going over, there's also a bunch of like wiring and piping and stuff that you need, a platform that supports all of that. And that's where Pivotal Cloud Foundry comes in to be extremely brief, we provide a lot of the platform services and what I would call like the all the iceberg below the waterline, all the stuff you need to kind of realize doing that better software stuff. And so specifically in microservices, as an example, we've among other things in Spring Cloud, which has been integrated to run as just a part of Pivotal Cloud Foundry. You can still run it independently if you want, but you can run it as fully integrated to Pivotal Cloud Foundry. There's a lot of things that we've pulled from the Netflix OSS stack that has lots of microservices supporting things into it. That's just available in Spring Cloud and therefore available in Pivotal Cloud Foundry. So it kind of gives you this toolkit right from the beginning, especially if you're using Java, to start not only writing and thinking about how you do your microservices, but also it gives you all of the production level operational things that you need, right? And it's sort of like a lot of our shtick is we think about what do you need end to end from writing the software, testing it, to actually running it in production, and then upgrading it and doing that whole loop. What do you need for that whole process? This is kind of the DevOps thinking. And we try to always make sure that in our platform, you have all of that stuff in there.
So those three pillars, there's this you get cloud native concept, there's the DevOps, and then there's the continuous integration, and then you discussed the different ancillary aspects of, building out the microservices environment, such as the wiring and then the platform overall with Pivotal and Cloud Foundry. Maybe you could take us through a little bit more detail of those three pillars and then talk about how those different wiring and platforms fit into that.
We'll look at continuous delivery as sort of like defining the thing you want to do. Now, before that, unless you're just like screwing around and like building software as art or a hobby, like you also have like a business that has some need for like whatever the business is like, I need to start doing better in software, and doing better in software means I want to be able to deploy it more often, because if I can deploy my software more often, not only am I getting more features into production, but I can start becoming a learning organization and say like, does option A for doing this work better than option B, like doing some A/B testing, and you can get feedback about improving your software, right? And if you look at a lot of consumer software, you can see that evolution as a user, right? Like there's frequently new things, functionality in Facebook, things move around a lot. It can be really annoying, like Google's infamous for just suddenly changing things and confusing people. But the happy path is you're always learning, figuring out how to improve your software, right? You're getting feedback on it. It's like learning how to be a better writer. The more feedback you get, the more painful it'll be, but the more better you'll get, ironically phrased, at writing. So if you don't have that pull from the business, unless you're just trying to impress yourself, everything we're about to talk about is probably a lot of hassle for you. You want to be able to deploy frequently. Now, there's some argument that like for security and quality, you want to deploy frequently, which is also true. But let's just think about the quality of the software.
This is difficult for companies. It's a problem I've heard people talk about in getting adoption for continuous integration. They often have issues, for instance, like integrating automated testing environments, because the QA team has historically been in charge of the quality assurance, right?
Yeah.
But actually, this is the role of a developer more so, to be able to then have that iterative loop.
Yeah. One of there's a good presentation by Home Depot at a Cloud Foundry meetup where they're talking about using Pivotal Cloud Foundry, and they found another blocker, which was basically like governance, right? And that can be security, networking, PMO people, whatever. And once they got a platform in place, like I was talking about, Pivotal Cloud Foundry's like all the wiring and stuff below the waterline you need. It's like once they got this platform in place, they could push code in like minutes if they wanted to, but it would still take them like 4.5 days. And they did like an analysis and found out that it was because they were just waiting on process and people, like meatware, if you will. So yeah, I mean, once you start optimizing your factory, you start finding all the bottlenecks, and they're often things that have been hiding out, like governance, because you've been so slow at getting your code ready. So that's why I think it's always important to have business motivation, because it's really only like the business executives, champions like that, who can really break up these log jams, right? I mean, I'm kind of going off on a tangent here, but I had never discovered this, but yesterday I came across like Larman's rules of organizations. And there's basically 3 rules. And one of them is like any large organization seeks to enforce the status quo. And so anything that new comes along is either seen as a hassle or just the same thing as the status quo. So someone has to come in and change that. I'm grossly simplifying it, but like the job of anyone is just to do the same thing over and over again until their boss tells them otherwise, essentially.
Then they do what the boss says.
Yeah. So you want to get continuous delivery in place. Let's assume that. And that implies, as you were talking about earlier, you need continuous integration and you need a way of delivering. And I would argue that the past 5 or so years of configuration management and automation and cloud think has been all about enabling all the automation you need for continuous delivery, right? Like we've got to move our ops fast enough, our automation, everything, such that we can actually deploy this stuff. So that's a goal you have. Now, once you get that in place, you need a process and a way of running your people, the meatware, as I like to call it, that supports a continuous delivery pipeline. And I think that's where a lot of DevOps comes into play. Now, like all of these things, any concept, in general, you end up to use a William Gibson phrase, I think, like the street finds its own uses. Like a lot of these concepts, their purpose was about half of what I'm talking about here, and half of it is like we're finding a use for these concepts. So to me, like DevOps came about from the consumer large scale web world because of two reasons. One, companies, these large .com companies, as we used to call them, they were having trouble keeping their systems up, bad uptime. So they needed to figure out how to change their software so that there would be better uptime. And at the same time, they wanted a continuous delivery process of getting features into production as quickly as possible, right? Like you know, there was some time where Facebook hadn't won, and they actually had to, and they still do, but they had to continue to compete on features and things like that. So they wanted to get features out the door and also couldn't go down. They needed uptime. And so I think a lot of what we see in the DevOps space comes from those two needs. And to grossly simplify it, it's basically amounted to, hey, so we used to keep developer and operations separate, and they had separate incentives, and they didn't talk to each other. And there was this, I think it was Andrew Schaefer who came up with like the wall of confusion. There was this wall between them. And so that doesn't help. Let's eliminate that and basically have them on the same team and have developers and operations people be responsible for everything. And then the end result is we can achieve those two goals of better uptime and also getting more features out the door more frequently. And there's a whole bunch of nuance and other things in there. And there's a tremendous amount of stuff if you start pulling on DevOps. And like, for example, I think one of the other tricks they do is instead of thinking about uptime, they think of resiliency. So like, if you can fix an error in production within minutes, uptime's not such a big deal, right? Like, it's more important to be able to recover from failure, which is just sort of like, that's probably would make a good 10-minute TED talk or something, some concept like that.
Recovering from failure?
Yeah, I don't know, some sort of think about things differently. Anyways, so you have DevOps that, and in that way, like DevOps is really sort of like the continual evolution of Agile, right? Like there's a good talk again from Andrew from maybe 2008 or 2007 at, I think like a Salt Lake Agile conference, where he basically went to the Agile community. He was like, you guys are doing great work, but do you realize that your code has to run in production too? Maybe you should start worrying about that. And so like, it's almost as if the DevOps is sort of like, well, playing that out. If Agile developers had to worry about running their code in production, what would that look like? So you need all of that as well, right? And then the third thing, getting to our topic at hand, is microservices. So how do you architect applications so that they can exist in that environment we were talking about? So that you can have an application that you can evolve every day, maybe multiple times a day, that has this resiliency that you can fix it, and that also almost the meatware issue is sort of like has a certain amount of understandability and independence across the people using it. And again, microservices is another thing where like the developer street has found its own use, so to speak, where a lot of the canon on it comes from ThoughtWorks and presentations there. And there's a couple of good talks and articles that sort of get on the reason that we're doing microservices is there's a couple of reasons. One, because we wanted to be able to independently evolve parts of functionality out of step of other things, right? So the opposite of this is the straw man monolith application, or straw person for those who don't like straw men only. If we have 5 services and we have to update each of those when we update one of those 5 services, then that's not cool. Then we only can release as slow as our slowest service in there. And instead, we'd like to independently release these things. And then another motivation was also we would like the teams to be able to choose any technology they want. There's an old phrase that comes into vogue every now and then. We want to be polyglot. Like, we don't want to have them only do Java or whatever. We want to use the right tool for the right technology. And if you've got a monolith, everything's so strongly coupled that teams basically have to choose one technology stack. So you start off with those two motivations and you do a bunch of projects for big banks and things like that. And then you end up with sort of like a microservices approach where you're extremely decoupling your architecture. And I think in a very real sense, you're having another go at service-oriented architectures with an emphasis of instead on data interoperability, an emphasis on independence and decoupling of the services from each other. And then what falls out from that, there's a great talk that I just watched actually earlier today from Sam Newman at DevOps this year. And he goes over kind of 8 principles of microservices. And there's another area that we at Pivotal care a great deal about. And that's like, as I keep saying, oh yes, you actually have to run it in production. And so there's a lot of other things that come into microservices, making it observable, as Sam Newman would say, and making it monitorable and making it upgradable, like all of the operations concerns, again, that come from a DevOps way of thinking. We, the team who owns this piece of software, are responsible for the full life cycle of it, right? Not just the development of it. So microservices also pulls in a lot of operational concerns. So, I just had as I was saying earlier, I just had 3 servings of some venison chili I made earlier. And like all of those 3 things are basically like a big pot of chili, right? Like you can pick out the meat and the tomatoes and the spices as separate entities, but you get them all together in a big pot. And then next thing you know, you've eaten too much chili because it's so delicious.
Like maybe we should call it a chili ops or something like that, Maybe not.
Yeah, see, that's why you and me are in wordsmithing. Come up with this stuff all day.
So then you get into the wiring and the platform environment. And so to talk about the platform and its role, I mean, it seems like you need these 3 pillars then to be able to really better understand and how to use and make the most of that platform.
I mean, I guess you could say that the platform's the dirt that these 3 pillars rest on, right? And also the dirt that the 3 pillars are made out of. We can really get lost in a metaphor hole here. What you do with the platform is, so let's start with like to pivot in metaphors. Let's start with the dirt. So you've got some data centers running somewhere, and there's some computers in there, and the computers are networked up, and so you need some standardized way of basically provisioning and configuring your cloud. Let's just call it a cloud because that's a cool word, right? Like I need a database. I want to run these applications on here. Like I need all this stuff running in a fungible cloud way, and I need to be able to deploy it and upgrade it and do all of that. So that's kind of at the infrastructure and infrastructure management layer. The platform basically takes care of all that stuff. So we at with Pivotal Cloud Foundry, we layer on top of VMware, OpenStack, Azure. If sometimes Google App Engine, I don't know if that's quite GA yet, and OpenStack, other things like that, right? So we have this basically interface that you satisfy, and if you write the 1817 things in this, Pivotal Cloud Foundry can install ourselves on that cloud, and then we can install services and everything. And then on top of that, basically you end up defining, this is how my application is going to look. Like it's composed of, you create a manifest. We use build packs, or you can use Docker containers. And this is how my application is packaged up. And you give it over to the platform, and the platform decides how to deploy it, and also configures it for you and does all the injection of configuration. Because what you end up doing when in a microservices approach is you tend to have your configuration injected into the system. So you'll hear words like discovery and registries and finding out where services are. And you do all of this, not to go all 12 factory, but you do all of this because it allows, when you do things this way, it allows your system to be more horizontally scalable. It's just a cloud-friendly way of developing applications. So again, the platform basically has a contract, if you will, a set of principles that says how you do all of that, how you model out and specify and have your I'm using the passive voice here, have your configuration configured. And then additionally, what the platform does, there's 2 more things, is there's also a bunch of middleware built into it. So you don't have to figure out how to get that middleware working. So we have like an HA MySQL database, a bunch of queues. You can add in your own things. Like if you have your own system, there's a way of plugging it into the platform so that developers can easily use it. And, there's mobile notifications. And I was mentioning Spring Cloud earlier. So there's a whole bunch of like, if I want to use the Netflix way of doing and managing microservices, that's built into the platform as well. As I always like to joke, the last important part is, and it runs it all for you in production, right? So all of that stuff, we sometimes think of it as an opinionated platform. It's sort of like, this is the, you know the French. What's the French word for a set menu? It's basically like, a set menu of stuff instead of a la carte. And, it's been paired wonderfully to taste well.
Prefix.
Yeah. You start with your pairings at the beginning. You've got your flavors that go, and you kind of end up with some ports or whatever. So everything's kind of combined together in, as you say, a prefix or whatever to work out together.
Yeah, that's just the menu where you can have they give you an option of, a nice salad or escargot, and then
sure. Now, of course, some people like to build their own stuff which that can be a thing as well. It just takes time to do it, and but it can be pleasurable for them, just like ordering a la carte.
Exactly. And, so I was thinking specifically about Spring Cloud when you mentioned it. I was actually looking at some examples of it. And I'm curious on what are some of the use cases that you're seeing for the kind of the integration of Spring Cloud and Pivotal Cloud Foundry and serving as platforms for building out microservices.
We have one customer, CoreLogic, and they're an interesting one to go to because they have been taking this cloud native approach for I think about 2 years now. If you include their planning process more than that, but they have at least 1 year of trying it out. You can go and look at our Cloud Foundry Summit videos of them, and their presentations are kind of similar year over year, but there's some lessons learned, so you can see the progress of it. And the types of applications, they go over some applications that they've done on the platform. And they're things like helping people manage apartments that they have, or helping condo people manage things. They're in the real estate business. At the high level, that's an example of the type of application that gets built on top of it. And you can imagine underneath there, I don't actually know the services they use underneath there, but you can imagine decomposing it, right? Like if you're, let's say you own five apartment buildings, right? With let's say 10 to 300 tenants in each. And you basically need services that connect to your backends to tell you like who's in there, like the address of them. You could decompose managing those apartments into all sorts of services, right? Like here's sort of like the maintenance thing, here's onboarding a new tenant, here's offboarding a new tenant. And so you could decompose those things into services, if you will, right? It's interesting to think through those examples because that's getting into microservices, a big, way of thinking about microservices that I think makes it slightly different than classic SOA or WS star stuff. Is you divide your system out into what I like to think of as business context, right? And a business context being things like a new person has signed up in the apartment, a person is leaving. It's like an end-to-end business transaction. And a lot of people use some fancy terminology that it's a bounded context. Bounded contexts are a little confusing, so I think a business context is better. So, and then if you look at other types of customers that we have, like Allstate is a customer that we talk about frequently, like Lockheed is another one. And in each of these instances, like the types of applications they're doing are not like super fancy pants. They're basically just taking what used to be analog processes and making them a lot more digital, right? Like Allstate, one of the areas that they're interested in working on more that you can see them talking about at CF Summit is they have like a roadside assistance program where like if you call them up, it's like AAA basically, and they're big with that in North America, and they would like to expand it globally. But if you think of decomposing that service that into a bunch of services, you need a service that looks up who the customer is, that looks up who your partners are in that region, that pairs them up, and then there's probably some remediation thing, like if that tow truck driver doesn't show up at 2 a.m., then what do you do, right? And so with all of these types of applications, you can start taking a microservices approach and breaking them down into a microservices way of doing things. And again, going all the way back to the business, the hope is that because these are new lines of businesses that we're getting into, or trying to revitalize, we're going to be continually updating the software, and we need the continuous delivery and DevOps and microservices, all supported by a platform that allows us to very quickly focus on turning those applications and learning how they operate. And they also need to be resilient and run.
This seems like the hard part where, and think about software, right? It's the most flexible thing you have, right? It's soft by description. And so you can iterate it, you can change it, you can use it to program different things, you can do all these fabulous and fantastic things that software has been come to be known for. But you also then have faced an organization that it doesn't build software, that does planning for the budgets or for the marketing or for the sales, and everything is very much process driven and planned and scheduled, and you don't fit into that. If you break the plan, everything falls apart theoretically. Development is often viewed as very strange because it doesn't work on those kinds of principles. You don't work on this very top-down method of application development.
Yeah, and I mean to interrupt you because that's for me a very exciting point. I don't know what to call this except maybe the real world software world impedance mismatch, right? Like a lot of what I've spent my time over the years doing is figuring out how to explain to normal people how software development works. And even more broadly, how software product development works. And you're I mean, as you're getting to, it's like it's not really how you think it works. I mean, there's all sorts of ways you can approach it. That I always like to say things in a very self-effacing, jokey way, right? So, like, my first thing is like the first thing you should understand about software development is we have no idea what we're doing.
Yeah, right. And that's the practice.
Right. And however, if like I've no really good there's two to me there's two types of really good software developers. There's a good software developer, and I mean this in aggregate, and they've figured out what they're doing and they just do that over and over again, right? And this can be why people like DBAs and security people are really good and also really annoying, is they're often, and I'm not one of those people, so I'm characterizing them, I'm sure they're a lot different, but they figure out how to do the same thing over and over again, and they're really good at it. But then when you want them to change or you want to do something different, it just they just want to kill you, right? Whereas the other type, and there's lots of software developers like this as well, right? The other type of software developer is really good at not knowing what they're doing, right? And so they set up systems where they can learn what they're doing, and they also have safety nets so that when things go wrong, they can quickly recover from it and learn from it, right? And this is why in the DevOps culture, well, I don't know if it's why, but in the DevOps culture, you see a lot of emphasis on learning and blameless postmortems. And like, there's so much emphasis. I would in fact say that probably the DevOps world spent a couple of years only talking about this topic of we need to become learning organizations.
Mm-hmm.
And I mean, really, with any software problem, the issue is that you're probably writing software that's never existed before and will never exist again, right? Like, it's just a really hard problem that you solve once and you can't really generalize it. And so you're continually having to sort out an unknown thing. And all this stuff we've been talking about, those three pillars in a platform, is built around, in my view, this notion that we have no idea what we're doing, so we should get really good at not knowing what we're doing.
Yeah, that is important. I mean, that and organizations usually don't work that way. They don't work that way at all. Yeah,
I've been visiting with some U.S. federal and government and military people recently, and it's interesting that they would probably agree with this point, that the way we used to operate, we assumed we knew what we were doing, and hence we had the classic waterfall things and big documents. But it's been real. I mean, being a U.S. citizen, it's been really heartening talking with them recently, because I saw a 2-star general earlier this week basically saying, like, we don't really know what we're doing here, so we'd like to learn how to do it better. And it's great. Like, they're cognizant of the fact that, like, software can be awesome, but you have to take a humbler approach to it than like big multi-year things that end up being basically death marches and failed projects. And
that's a breakthrough.
Yeah, it'll be wonderful to see that spread out more in the government, because man, it's fun and everything for me to like talk about in Twitter, like to come back to it, eating chili and like keeping up with my high school friends and getting infuriated by all the people in Facebook who really like, crazy politicians and things like that. But like, I feel like anytime government IT improves, it probably has the most maximum effect you can have on overall good possible.
I was thinking that about the state of Oregon, right? If the state of Oregon suddenly decided to put all their emphasis into that kind of thinking, we'd have a different kind of a place. We'd have a different kind of a state,
Yeah. Now to take one of my favorite items, there's one item we should fix first, and that's meeting scheduling. Fix it globally. I think GDP would increase 10% globally, right? Like, just think of how annoying it is to schedule meetings, and there's no reason.
Aren't you a doodler? Do you use Doodle?
I do. But now we have the situation of like, there's 1,000 different ways to fix the problem. We should just all fix it one way, right? Like, we just all need to like email. Email is fixed. I mean, now it's fixed so much that people are overwhelmed by email, but we haven't really fixed scheduling meetings in the same way that we fixed email, right? Like, email just works. But if you want to schedule a meeting, it's just a poop show to PG-13 the phrase.
It's it's meant for failure.
So fix the meetings and then fix government IT. That's what I got for you this year. Merry Christmas.
Well, there's always a new year, at this time of year, so you can celebrate Christmas and meeting fixings, and have all the fixings in the turkey too, so it works.
Oh, nice gliding off words there. Good job.
Thanks. Well, Michael, I think this has been pretty good. Any last thoughts you'd like to share, your wisdom at the end of the year on microservices and venison chili?
Sure. Well, on the chili, I found this recipe and you put some cinnamon in it. And I think along with some fire roasted tomatoes from a can, that's what really seals the deal there. Now, that's enough for listeners out or watchers out there or whatever. Yeah, but on the topic of microservices, so I was at the Gartner AADI conference last week, and I talked with a lot of analysts and people, customers, enterprises, whatever, about microservices. And as you know, right, like the whole reason you're doing a series on like containers and microservices and stuff, there's a tremendous amount of interest out there. And what I would say is don't be too afraid of it, right? Like I think over the next year we'll see a lot of FUD about microservices, like they're too complicated and people don't need them, and what you actually need is this other thing. And I think you can construct a series of definitions that are very strict that would lead you to that conclusion. But I think if you just look at microservices in the way that I look at DevOps as the evolution of Agile, think about microservices as the evolution of SOA. And be curious and explore, and also realize that there's not really any one perfect way of doing microservices yet. So now is a great time to go in and investigate and try out various ways of doing it. I mean, we obviously think that we have a great way of supporting multiple different interesting ways of doing microservices. But I think microservices will be more applicable to the market as a whole than most people might be talking about in the next year, right? It's not just for the unicorns out there. I think to use my metaphors, the war horses and the donkeys would do just fine with it. Ultimately, what you get with microservices, I think, this is my theory, is runtime and architectural resiliency, right? And that is, it allows you to operate in the lower two quadrants of the Rumsfeldian quadrant of knowledge, your known unknowns and your unknown unknowns, where software development resides. And I think it's a good context sort of safety net to operate in if you're in that area. And I'm pretty sure any size team could take advantage of it.
That seems to be a theme I've been hearing, at least for example, at Node Interactive, the conference here in Portland this week. They talked a lot about just simpler ways to do things. Node is embraced, because it is JavaScript, but it's just easy to do, and you can build apps pretty quickly with it. And then you have on the back end now, you have container technologies, and those are a good combination for microservices, right? So
No, and to that end, you're reminding me. If you are going to have show notes, we should put it in here. But there's a good presentation by a colleague of mine, Matt Stein, where he talks a lot about the study of how ants operate, right? And as an analog for architecture, and it's essentially like ants have some really simple principles that they follow, like literally brain dead and stupid simple, because they're ants. And they build upon these really simple principles to do really complicated things that you see ants doing. And that's a good analogy for thinking about how you architect and what you're talking about, right? Like the simpler you can keep every concept, like every sort of cul-de-sac of a concept, the more complicated things you can build reliably, right? And I think microservices is a go at that. Like a lot of DevOps think is a go at that. A lot of what you see in the cloud native space is trying to build complicated things out of simple bits. And, he's got a good book you can get for free. It's like 50 pages. It's like, what is it? Migrating to cloud native application architectures. And that kind of goes over, I don't think he has his ant analogy in there. That's in a newer presentation, but it also goes over a lot of practicalities of figuring out microservices and building them.
I also was at HPE Discover last week in London, and I met this guy, and I actually met this guy, Gary Gruber. Have you met him?
He's one of those people, like, I'm pretty sure I do know him, but I probably know his Twitter handle and avatar better than his actual meat face.
Yeah, and Gene Kim was there too. And
yeah.
They talk a lot about this. And the kind of the question I have increasingly about this is, okay, so yeah, we're making it, Node, lightweight containers, and that might kind of help, reduce the complexity to some extent, for instance, with keeping everything updated and so on and so forth. But that there's complexity that's going to go elsewhere as a result. That seems to me like it must be one of the big challenges for companies, because they find ways to simplify one core aspect of building out, microservices environment, but then that complexity has to shift somewhere else.
I think that's a great point. And that's a lot of, I think of it as a balloon, right? Like if you want your balloon to be thinner, you can squeeze it, but then it's just wider somewhere else, right? You're just displacing I don't know what this was. That looks like fun. But so one area of balloon expansion or complexity goes down to the platform. And so the first step is sort of like, let's remove complexity. Like, let's suck air out of the balloon somehow. And the way we solve it is we basically remove options, right? Like, there's less moving parts. And if you go back to those core logic videos, you can kind of see a as is before state and an after desired state. And I see this, I go on a lot of customer calls nowadays, and I see this at every single customer. Every single customer thinks that they're like an Anna Karenina family. Like, they're uniquely screwed up and in their own special way, but pretty much all of them are screwed up in the same way, which is the following. Over the last 10, 15 years, whenever you built an application, you could choose anything you wanted all the way down to the server, right? And I'm exaggerating, but you end up with lots of operating systems, lots of middleware. You have this huge variety of things.
Right.
And it turns out that's a lot of complexity. Right? Like 10 years of basically application teams choosing whatever they want.
There's stacks everywhere.
Yeah. And then so if you go back and look at those core logic slides, you can see the one slide where they've acquired a lot of companies. This is another way you end up with it. And then you just end up with I think they have 5,500 applications across anything you want, right? Obviously, migrating from that is a problem. But when you're starting off new, part of what we do in the platform is we basically moot that point by not giving you options, right? You're just yep, you just tell us the application you want to deploy, and you don't get to choose the operating system. There's always exceptions for something as big as Pivotal Cloud Foundry, but in general, it's just like for example, we get a lot of people asking us well, do you run Red Hat, RHEL or whatever? And the answer is why is that even a question? Right? We manage the operating system for you, and we manage this, and why don't you just worry about other things? And that can be an annoying, arrogant question, but it's our way of trying to address and decomplexify at the platform layer, right? So if you have less operating systems and less ways of doing networking and less networking issues, then that removes a lot of complexity from it. And maybe you can use that complexity further up the stack in the application layer where you're actually making money and not just at the infrastructure layer.
Yeah, understanding what your constraints are and what what you want to have done for you, so you can live within those constraints. Even I think this is a good lesson, because even the most experienced technologists don't want to have to do everything themselves, nor does anyone in any kind of role. I mean, it's why we use WordPress, right? It's an opinionated platform. It has its constraints, but we live with them because, we want to push out stories during the day. And if we had to do something, if we had to do a lot of the work that they do, then we would never really get anything published.
Yeah. It's not like 2001. It's like there's options. You don't have to roll your own blogging stuff.
Yeah, you don't have to manually craft your own RSS feed.
You might have to use some funky WordPress shortcodes for things, because they apparently don't know how to deal with HTML. But whatever. That's a good small example of compromise, essentially.
Mm-hmm.
Like architectural compromise that you make. You can't just slap in a YouTube video embed. You've got to use their weird little bracket things. But then there's a whole lot of other stuff you don't have to do that's really annoying.
Michael, thank you for taking some time to talk today about microservices and the pivotal approach to microservices. And we've covered a lot. We've covered your three pillars, kind of the microservices world, the DevOps world, and continuous integration. We talked about platforms and microservices. platforms and the wiring that, that comes with it, the organizational culture. We even talked a little bit about venison and, and a lot of other things in between. So thanks for taking the time.
Yeah, absolutely. I'll see if I survive these 3 servings of chili. It might be a rough afternoon, but it was a delightful lunch.
Great. All right. Thank you.